It's June 17th, 2024. This is Codespaces, a company that hosts source code and project data for other teams. For its customers, this is where software project lives. Then, traffic starts flooding the service. Normal users struggle to get through. Codespaces calls it a distributed denial service, a DDoS. But while the public attack is happening, Codespaces discovered something worse. An unknown attacker has access to the EC2 control panel it uses to run its cloud servers. This control panel matters because it's not just a settings page. It controls their cloud infrastructure. From here, someone with access can start servers, stop servers, delete storage, and remove recovery assets. The attackers leave messages asking Codespaces to contact them through Hotmail, then demands money. And when Codespace tries to regain control, the attackers begin deleting the pieces that the company needs to survive. Pause on that sequence. The DDoS does sound scary, but it's simply being used for smoke and mirrors. The deletion does not happen because traffic is heavy. It happens because the attacker has access to the cloud control panel. One attack is making Codespace hard to reach. The other is erasing the way back. So the question is not who hacked one server. Codespace has said the attackers do not have access to private keys needed to log into the machine. The question then is bigger. How can someone who cannot enter the servers directly still destroy the servers from the outside? Why do the recovery copies disappear before they can save the company? And what does a real cloud backup need to survive? This is the story of Codespace's shutdown, based on reporting from SC World, The Register, Security Planet, the Public Cloud Security Breaches Catalog, and AWS Cloud documentation. The public sources do not prove exactly how the attacker first gets access into the control panel, so we will follow what the sources show and what that access allowed. Here's a simple AWS architecture. For those that are not aware, AWS stands for Amazon Web Services. It is Amazon's cloud platform, a place where companies rent computing power, storage, networking, and security tools instead of buying all the hardware themselves. Codespace runs their important parts of their service here. On this architecture, the first things we need to understand is the service layer. This is Amazon Elastic Compute Cloud, usually shortened to EC2. EC2 is the AWS service that is used for running virtual servers. A virtual server is a computer that you rent in the cloud. It will typically have CPU, memory, an operating system, and applications that run within it. But it will live inside Amazon's infrastructure instead of inside your office. Running virtual server is an EC2 instance. Codespaces relies on these instances to run parts of their platform. The EC2 control panel will sit above these instances. AWS describes the EC2 console as a web interface for creating and managing EC2 instances and resources. So panel access is different from logging into the server. Logging into the server means entering the machine. Using the control panel means changing the machine from the outside, simply to launch it, stop it, terminate it, or change related resources. This is why the private key detail is not enough to save Codespaces. Attached to these servers are disks. In AWS, this is what we call Amazon Elastic Block Store, or EBS for short. EBS provides storage volumes that attach to the EC2 instance. After you attach one, you can use it like a hard drive on your computer, store files, install applications, and keep data. If the EC2 instance is the running server, the EBS volume is the disk that it will use. Losing this disk can mean losing what the server needs to function. Now the recovery layer. This is the EBS snapshot. A snapshot is a point-in-time backup of the EBS volume. It captures the state of a disk at a specific moment, so you can restore a new volume from it later. Codespaces needs snapshots because if a disk fails or a server has to be rebuilt, the snapshot is the only way back. Besides this is an Amazon machine image, or shortly called an AMI. An AMI is a saved image that provides the software required to set up and boot an EC2 instance. It can include the operating system, software, configuration, and the block device mapping AWS needs when it is launching the server. The purpose of it is speed. Instead of rebuilding a server by hand manually, you simply just launch from the image. And then there is the Amazon Simple Storage Service, or S3 for short. S3 stores data as objects inside containers called buckets. A bucket is the container. An object is a file plus its metadata. Companies use S3 for object files, export, logs, backups, and application data. Now the deletion makes sense. Codespaces said the attacker removed the EBS snapshots, S3 buckets, AMIs, some EBS resources, and several machine instances. This is literally all of their servers, storage, server templates, and recovery copies all being hit from the same control panel. Normally worst case, you'd restore from backups, but what if your backups are deleted as well? Codespaces tries to take back by changing the password, but the attacker has already prepared for that. The company says the intruders created backup logins to the panel. In instant response, this is the part defenders fear. Removing just one door does not help if the attackers have created multiple other ways to stay logged in. Codespaces is still trying to lock the account while the attacker is still in. This is the major architectural flaw from my view. A backup is a copy that attackers cannot and should not be able to delete. It should be in an isolated AWS environment that is locked down. Unfortunately for Codespace, this is not the case. Codespace has said most of its data, backups, machine configurations, and off-site backups are partially or completely deleted. The events reportedly unfold within 12 hours. 12 hours is one single night shift. Enough time where Codebase contacted support, attempted to change passwords, in real time see the damage, they make a plan, the plan is lost, and watch another recovery asset disappear by the end. The ending of this is harsh. Codespaces says it cannot operate beyond this point, and has no alternative but to cease trading while helping customers export whatever remains. The public cloud security breaches catalog lists the current status of the threat actor as unknown and says no one has ever been identified as the perpetrator. So what went wrong? The modern lesson here is not to never use AWS. The lesson is defense in depth to control the blast radius. AWS recommends multi-factor authentication and least privileged permissions, which means giving identities only the permissions required to perform the task. An everyday account should not be able to delete a recovery asset, and the most powerful credentials should not be treated like normal logins. For recovery, AWS Backup supports copying backups to separate AWS accounts. In this instance, this would have been imperative because if the original backups were deleted, AWS allows you to create a copy from the backup of its destination back to the source account, and then start restoring it. AWS Backup Vault Lock can also add a protection layer against accidental or malicious deletion. When in compliance mode, after the grace period, the lock cannot be altered or deleted by the customer, account owner, or AWS while it contains recovery points. Codespaces was not destroyed simply because their cloud storage stopped working. It was destroyed because the attackers were permitted, due to the lack of controls within the environment, to acquire full access, create redundancy admin roles, and the ability to delete backups, and no proper instant response procedure was there to mitigate the threat. This is the real cloud lesson. In AWS, servers, disks, templates, buckets, users, and backups can all become buttons. That is powerful. It is equally dangerous. Because the question does not just become, will this one control protect us? It is, how do we lock down each part of our systems to reduce the blast radius?